Hello kids and welcome to your video on functional or function notation. So I've had to go back all the way, I've done the entire video actually, and now I've gone back to the beginning and had to re-record this first slide because I was going to do something really cool and play a video within a video, but it didn't work and I couldn't get it to work. So if you haven't seen it before or if you don't remember, take the 7 minutes and 45 seconds that it takes to watch the metamorphosis video. Because it is just downright hilarious and awesome and a great way to review functions and inputs and outputs and so on. I know that may put you over your 15 and a half or 16 minute mark for tonight's video, but I think you'll get over it. So if you haven't watched it before, if you don't remember, go watch it. If you don't, there are going to be references to it throughout the video and then you're going to feel left out. So you might as well. Look at that cute chicken. Don't you want to know what happens to the cute chicken? Anyway, let's actually get into the instructional portion of our video. Okay, function rules. When a function rule describes the relationship between the points of a function, we can write it in function notation. An algebraic expression that defines a function is a function rule, and a function rule is written as in the form of an equation. It defines the output based on the input, and the x's are the input, and the f of x is the output. And I'm going to summarize that a little bit later. So go ahead and let's keep moving. Okay, in function notation, the dependent variable y is replaced with terms such as f of x. So this is going to sound a little like science, but your independent and dependent variable come up in math just like they do in science. Your input and your output. And I should say independent and dependent, input and output. The letter f is the name of the function, and x indicates that the output is dependent upon the input x. In other words, the output is defined in terms of the input. So just like when we were solving word problems and we defined a value in terms of x, that's really what the output is, or what that function, that functional notation, that's what that f of x is the output. F of x is the output, and therefore it's interchangeable with y. So we'll see f of x and y used interchangeably. Although there is a difference, y is never distinguishable. F of x, you can change the letter. We'll see that in a minute, so you can distinguish between functions. Okay, f parentheses x is read f of x. And this is important, because the way that we speak in mathematics is important. When you walk into any university in the country, really on the planet, even if it's not an English-speaking country, when you say f of x, they probably know exactly what you mean because it always means the same thing. And it's because it's f stands for function. So f of x is basically an abbreviation for function of x. So f parentheses 2 is read f of 2, and it means an output of the function f for an input of 2. Any letter can be used, although F, G, and H are the most common. F because of the word function, G and H because of their proximity to the letter F in the alphabet. G of 4 is read, G parentheses 4 is read G of 4, and it means, again, the output of the function, this time function G, for an input of 4. It's really important you remember F parentheses x is not F times x. F is not a variable, okay? It's an abbreviation for function. So your independent variable, that's your x. We already know that's the domain, that's the input. The dependent variable, that's the y values coming out, that's the range, that's the output, that's the f of x. So independent and dependent variables is something we'll discuss further in class, but let's move forward. Okay, next we're going to look at writing a function rule. So we make our function rule up based on what we have in the verbal problem. So here we have example 1, each loaf of bread costs $2. So we're going to write a function rule, and we're going to write it as C of B. Okay, and C of B is going to represent the cost of the bread. And basically all you do is set it up like an equation. So what do you do to find the cost of the bread? It's 2 times the number of loaves. And in this case, we're going to use B to represent the number of loaves, 2B. So you might have C equals 2B if it was an equation, but being a function, we write it C of B. C of B. Okay, and you could easily have used f of x as well. It really doesn't matter. I just like to use variables that match what's in the problem. So let's do the next one. Admission to the carnival is $5 and rides cost 75 cents each. All right, so the cost of the carnival. So the cost of the carnival, let's say C of what? It's a function of what? The cost of going to the carnival is a function of is a function of the number of rides you want to ride. Of the number of rides you enjoy. So C of, we could say C of R. And how would I write that? Well, it's $5 to get in and 75 cents each ride. And we have not struggled much writing function rules like this so far this year. You're going to see a few of these in class. Just to get some good practice in. So $5 plus the 75 cents per ride. And we know 75 cents per ride has been 0.75 times R. Okay? All right, so there's a couple function rules. Let's continue. Now, evaluating a function. To evaluate a function, you're going to plug in an input to find the corresponding output, which is usually a number. And this is where they used to give you those good old function machines, just like our Nuggetizer video. And they would have they would sort of look something like this, and it would have like a box, like this. So I'm not good with perspective drawings at all, but let's just pretend I am just for a second. Oh, that's actually not bad. All right, and then this would be the output. Okay, so that's actually really good for me, isn't it, guys? Aren't you proud? So your function rule could be anything. Let's say it's x plus 5. Well, the number we put in, say -2, goes into the function, okay, just like the chickens, and the function rule acts on the number, and out comes the output. And that's evaluating a function. But this is like the 5th grade SOL version right here. This is what it kind of looked like back before we wanted to put the right symbols on it. So let's look at what the right symbols would actually look like. And here I've written 5 function rules: f of x, g of x, h of x, j of x, and k of x. And again, f of x because f stands for function. The rest of the letters because of their closeness to the letter f in the alphabet. And we're going to evaluate each one with one value. And we're going to do this together. So I'm going to go ahead and write this out. Now, if you are quite comfortable with this and you want to just go ahead and jump forward to looking at your solutions, pause your video, do it yourself, and then you can look at the solution here, or not solutions, but the values. All right, starting with f of 4. So f of 4. So we've got our function rule here is 3x minus 4. So we're going to write equals. We're going to put in the 4 for x, and then we're going to evaluate. So 3 times 4 is 12, minus 4 is 8. So that's all it is, f of 4. The value of f of 4 is 8. So it's just plugging in and doing the math. Plug and chug, if you will. Next one, g of x is equal to x squared minus 9x plus 1. Now we keep getting burned by this. Please remember to put your negatives in parentheses when you plug them in. So plug in my -3's, -3's. Oop, my 3 looks like it has an extra bump on it. All right, -3, the quantity squared is positive 9. Minus 9 times a -3 is going to come out plus 27, and then plus 1. So I'm going to use the commutative property in my head to make that easier. 9 and 1 is 10, plus 27, 37. Come on now. Okay. Sorry, struggling with my writing on the iPad tonight. All right, next one, h of x. So h of x here is 2/3 x plus 4. So we're going to find h of 9. So we're plugging it in. So 2/3 of 9 plus 4. 2/3 of 9, well, let's see. 1/3 of 9 would be 3. So 2/3 of 9 would be 6 plus 4 is 10. Okay, j of x. J of x is negative x to the 3rd power. Now, what's the reality with this one? I'm not going to say anything until the next page where you're going to do one more set on your own, but let's think about what the reality of the sign of this actually is. Okay, but I'll go ahead and write it out anyway. J of x. So j of, I didn't mean to write that. J of -5. So the negative sign, -5 cubed. Okay, so I've got a negative sign out front, and then I've got the negative sign on the -5. So -5 to the 3rd power would be -5 times -5 times -5, which would be -125. But that's the -5 to the 3rd, and then I've got the negative sign out front, so this is going to come out positive 125. Okay, think carefully about that. Okay, good. Last one, k of -8. Well, k of x is 15 minus x. So k of negative 8 is going to be 15 minus negative 8. Again, put your parentheses in when you're plugging in your negatives. All right, we know that means it's really adding because it's keep, switch, switch. Add together, we're going to get 23. So the value of k of negative 8 is 23. Okay, one more set. This time I really do want you to write them down. You should already have the function rules written down. If you haven't written them down, write them on this slide now before we go to the next one. So I want you to go ahead and evaluate these functions. For these values this time, and write it out carefully, I'm going to pause the video. I'm going to write it all the way out. I'm going to play the video again. I'm going to walk you through my answers. Ta-da! There's all our answers. So let's go through them. F of negative 3 is 4 times negative 3, negative 12, minus 4, negative 12 minus 4, negative 16. G of 5, 5 squared minus 9 times 5 plus 1, 5 squared 25, minus 9 times 5 is 45, so 25 minus 45 is negative 20, plus 1, negative 19. 2/3 of, so this is h of negative 12, so 2/3 of negative 12 is negative 8. 1/3 of 12 will be 4, and it's negative, so negative 4. 2/3 then would be double that, would be negative 8. Plus 4, negative 4 is the answer. And then the next one, j of 5, the opposite of 5 to the 3rd power. So I asked you to think about this one. This one does something interesting. You know, given it's a cubic, we know that when we cube a positive, we get a positive, but when we cube a negative, you actually do get a negative. So the negative out front on this one, what it's going to do is whatever the sign of what you plug in is, you're going to get the opposite sign for your answer, because it's always going to flip it for you. So in this case, 5 to the 3rd, 125, and then the opposite of that, negative 125. And then finally, k of 9. So this time, 15 minus x, 15 minus 9 is 6. Okay, so I've come back to re-record over, and I know sometimes that ends up giving me kind of duplicate writing on the slide, and I hope it doesn't. But if the metamorphosis video is not something you took the time to watch and you didn't understand my references throughout, you know, I made this video originally metamorphosis. God, that looks weird. Anyway, sorry. I made the whole video with the intention that you would have watched the video inside this video in the beginning, but I just couldn't get it to work. So that's why I went back and I redid the first slide of the video where you actually have the YouTube address and the picture of that cute little chicken that meets that really disgusting death, but chicken nuggets are just so good. But anyway, if you didn't watch it in the beginning, and you didn't get my references, take the time to go back and watch it. It is absolutely worth it. There's apparently a spelling mistake. It's either a spelling or a grammar mistake in the video. So if you if you find it, let me know. I would definitely be willing to reward the finder with, I don't know, a fresh new mechanical pencil. So, all right, guys, I thank you for watching, and I will see you in class.